And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless. For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Hovind, you have completely ignored genome sequencing. Now this is going to take a while, but I have been wanting to kick this dog for a long time. What is this genome sequencing they're talking about? You completely ignore the genome sequencing data observed over the last 3 years. You are out of date. You ignore and completely the detailed phylogenetic observation written way before Linnaeus. Does not make it correct. This is a logical fallacy. I'm amazed you still don't know how stars are formed. Gravity. We could take 3 days on any one of these. Now listen carefully, Robert. Gravity is not going to pull a bunch of dust together to make a star. Zero probability. It's never been observed. It's not science. This is your religion. I'm going to leave that one for another night. I don't have time tonight, but we can take it up if you'd like. Bring it up in another question. We're still letting you make your dumb comments on our YouTube channel. Okay. Genome sequencing is, according to genomenewsnetwork.org, is the figuring out the order of the DNA nucleotides. DNA stands for deoxyribonucleic acid. That is the instructions to make you. How many lines of code are there in a computer program?
Not nearly as many in DNA.
Hundreds of thousands, maybe millions, right? Okay. The lines of code to create you is your DNA. You got half from your mother and half from your father. Ask your mom to explain it to you, okay? So, figuring out the order of the DNA nucleotides or bases in a genome. The order of A, C, Gs, and Ts. I told my students CAT, C-A-T-G is an easier way to memorize it. There are 4 different types of bases, C-A-T-G. Now, in computer language, it's only binary. There's only 2, zeros and ones. But in the DNA code, there are 4, C-A-T-G, which means it's about 1 trillion times more complicated. Our English language has 26 letters. How many possible combinations are there of those 26 letters? Nearly infinite, right? Okay. So, the human genome is made up of over 3 billion genetic letters. Imagine a book with 3 billion letters in it. That'd be a pretty good sized book. Okay? I think the Bible has 750,000 letters. 750,000, I think, is correct in the whole Bible. Less than 1 million. Can you find out? Anna, okay. 750,000, something like that. Anyway, so maybe that's words. How many letters in the Bible? Maybe it's a couple million. But this is 3 billion with a B. Okay, you got million, billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, novillion, decillion, all the way to centillion if you'd like. We can count as high as you'd like. Okay, so they're saying they're figuring out the order of the letters of the code. Oh, interesting. Nucleic acids consist of a chain of links called nucleotides. The possible letters are A, C, G, and T. Does it have how many letters? Anna?
It's still loading.
It's still loading, a big old number. Okay. Representing the 4 nucleotide bases of the DNA strand. And here they are right here, A, C, T, G. Okay. Covalent, they're linked with a covalent bond, okay? The sharing electron. Linked to a common backbone. So you have all the different CATG letters all linked to the common backbone and then twisted in the spiral. The genetic code, the DNA, the information to make you. And they have these sequences in letters. Is it CATG or CGTA or CAAACTG? It can be, and it's all spelling a different word, a different bit of information. Yes?
3.5 million.
3.5 million letters in the Bible. Okay. So the 750,000 was the number of words. Okay. 3.5 million letters. The code to make you has 3 billion, which is nearly 1,000 times more than there are letters in the Bible. Okay, so they compare the sequence of these letters. Humans, chimps, gorillas, and orangutans, they've looked at the sequence. Look at the order. Is it C, T, C, 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 G, A compared to what's in the other creature? Okay, now there are 4 different ways you can compare this. Robert Oppenheimer. You can look at the similarity of how many base pairs are there. In the case, humans have 3 billion. Bacteria have 4.6 million. So humans have about, what would that be, 700 times more. Okay. You could look at the number, how many base pairs do they have? Okay. Or you could look at simply how many chromosomes they have. Total number of chromosomes. Humans have 46. A mouse has 40. A plant might have 10. A certain plant here. Let's see. A rhododendron has 12. So are we going to compare the chromosome number? Or are we going to compare the base pairs? Bacteria only has one chromosome. One, okay. Or should we look at the estimated gene count? Humans have about 25,000 genes, okay? Whereas plants might have 25,000 also. Wow, proof we're related to the plant. If you want to arrange all the creatures, all the life forms in the world based on this, you're going to get a very different chart than if you base them on this. And you're going to get a different chart if you base them on this. So they're picking the one they want that matches their stupid theory the best, that we all came from a rock 4.6 billion years ago, which came from a magic dot of nothing that exploded. I am tired of putting up with it. I guess you can tell. Okay, here's an example. Homo sapien, that would be man. It is A, T, G, G, C, 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 T, G, T, G, G, and they sequence. They paid somebody to do this. Sit there and write all this out. Okay. Then you've got the different creatures down. Here's the gorilla. Here's his sequence. And here's the Canis lupus. Oh, wow, the dog, okay? And they've got all, oh, there's a different one. Look, we got a G and they've got a C. Oh, the dog is different than a human. You had to look through a microscope to figure that out? Are you dumb in any other area? Or is this the only area you're stupid in? Come on. So they give the sequence of, they're simply making the sequence of all the letters. And then determining how similar they are. Okay. Example. Humans and chimps. Look at this. G, C, 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 A, T, A, A, C, C, A, C. And the chimps are, oh, wow, they got a difference with the T and the G. Look at that.
But what part are they even comparing? And if there's
Out of the 3 billion.
Yeah,
What are they? That's the whole point. They're comparing little slices of it, finding. I would predict, without even knowing about DNA, that there would be similarities in the code to make a human and the same code to make a chimpanzee, because we both have, like, 2 eyes on the front of the head and 2 ears on the side of the head and a mouth and a digestive system, and there are probably millions of similarities. Okay, so it would require similar code to make those parts. Does that prove common ancestor or common creator? Think about it if you're capable. Okay, how about this one? One little change. Woman, without her, man is nothing. How about woman, without her, man is nothing? Same letters, changed the comma to a different place. Wow. The top line has 35 lines and spaces. The bottom line has 35 characters, lines, and spaces, and a punctuation. So they're nearly 100% similar, but they mean something totally different, don't they? A woman without her man is nothing. They asked a college professor for the students to said to students, put the punctuation in. All the men wrote, a woman, comma, without her man, comma, is nothing. All the women wrote, a woman, colon, without her man is nothing. Same words, slightly different, little bitty, 0.01% change, and has a totally different meaning. Okay? Consider the following pairs of sentences. John is easy to please. John is eager to please. Just a couple letters difference. Totally different meaning, right? Top line has 27 letters. The bottom line has 26 letters and characters. It's time to eat, comma, children, or it's time to eat children. You think maybe those have different meanings? With one comma missing? One comma. It's time to eat children. Oh, really? Do they taste good? So yes, one little tiny bit of DNA code could make a really big difference, okay? Let's eat, Grandpa, or let's eat, Grandpa. Is it let's eat, comma, Grandpa, or just let's eat, Grandpa?
Well, depends where you're from.
Depends where you're from, yeah, okay. How about eat your dinner is not the same as eat your dinner? Think about it long and hard, Robert, okay? These little tiny changes just in our simple English language can obviously make huge differences. So sometimes similar lines of similar sentences with one little minor difference might mean something totally different. It's the same in the DNA code. God is so smart, he wrote a code base 4. Yeah, 4 different instead of just base 2 like our crazy little simple computers that use just zeros and ones. Oh no, God did it with 4. Trillion times more complicated. Now, sometimes things have zero similarity, but they do or say exactly the same thing. I love you very much. Please come home. Je t'aime beaucoup. S'il te plaît, viens à la maison. Identical, but it's in French now. Ich liebe dich so sehr. Bitten komm nach Haus. I love you. Come home. Oh, yes. Yes. No wonder the Germans lost the war, right? Okay. Here it is in Spanish. Here it is in Russian, Chinese, Norwegian. Same message. How many letters would be similar? Not too many. But they're saying the same thing. So it is not correct to say we can line up the CATG and find a sequence and make it mean anything, that we're only 10% different than this animal, therefore we're related. That's how they're figuring out these stupid phylogenetic trees and where to draw the line. That's how they're doing it. Sometimes one sentence can make totally different meanings based on the inflection. I never said Bill stole the money. I never said Bill stole the money from the store. I never said Bill stole the money from the store. I never said Bill stole the money from the store. I never said Bill stole the money from the store. I never said Bill stole the money from the store. He stole it from the bank. Each one is a totally different meaning. Same identical sentence. 100% identical. Totally different meaning, just simply based on the inflection. There's such a thing as recessive genes. The gene is there, but it's not expressed that generation. It might come out 5 generations later. Now, the textbooks are going to say we have evidence from molecular biology, which is what our nuclear physicist wannabe here is telling us here. Evidence from molecular biology. DNA, Darwin speculated that all forms of life are related through descent with modification from earliest organisms. This speculation has been verified. Oh, really? That textbook's right on that shelf over, I forget, it doesn't matter. But I got all these textbooks here. And I taught biology for years, and most of my I have some 2017 textbooks over here, but most of my stuff is, they put me in prison 10 years, okay? I didn't collect textbooks during that time. Okay, so this is one of the lies in the textbooks from my video number 4. Lies in the textbooks. And you can get this and give, if you know any kid going to public school, any kid going to public school, buy a stack of these from our ministry and pass them out to every kid and say, kid, I'll give you $10 if you'll watch this. This one right here has helped hundreds of thousands of public school kids. It's also part of our seminar series if you want to get the whole thing for $50. But if you want to get just singles and give them out to anybody, go wait at the bus stop when the kids are going to get ready to get on the bus and give them one. It might save their life, okay? Okay. The DNA, the chromosome, the deoxyribonucleic acid, is the most complex molecule in the universe. Incredibly complex. It's not only just little lines of code, the CATG. They are twisted up, and then further twisted, and then further twisted. And they not only act with each other across the rungs of the ladder, they act with the one they touch above it. It's a code written in 3D.
But they're missing the whole point, though, because even if the code is in the right order, without the RNA to read it and understand it...
That's another whole level of complexity.
Yeah.
But the DNA code is incredibly complex. It's a gross oversimplification to say that DNA has only 4 basic parts. Each of these parts is also incredibly complex. So it's a phenomenally complex molecule. This is the code to make life, right there. The average human has about 50 trillion cells in their body. 50 trillion with a T. The total from all of the DNA out, if you extracted every cell in your body has 46 of these chromosome strands, except for the gametes, they got 23. If you extracted all that chromosome material, it would barely fill 2 tablespoons. But each one of those, and there's 46 in each cell, and you have 50 trillion cells, each one of those little DNA strands, if you unwound it and stretched it out, would be 6 feet long. That's one strand of code out of a whole bunch to make you. If you unwound the DNA code just out of one person and tied them end to end and stretched them out, the chromosomes from one person would go from Earth to the moon and back 550,000 round trips to the moon. That's the instructions to make you. Maybe that's why David said, I am fearfully and wonderfully made. And he didn't have a microscope. He knew nothing about DNA, but he's smart enough to know he's fearfully and wonderfully made. You would think now, with all of our microscopes, we'd be even more praising God for what he did. This is incredible. The code in the chromosomes is far more complex and holds more information than all computer programs ever written by man combined.
So it makes you wonder how much they've really compared.
Right. Even Bill Gates said DNA is like software program, but it's much more complex than anything we've been able to design. Okay? IBM models its newest computers after DNA. The quantity of information is so vast, we have to invent new numbers to measure it. Not just terabytes or petabytes, but exabytes, yottabytes, and zettabytes. All the words ever uttered by everyone who has ever lived would amount to 5 exabytes. The DNA code is so complex. If you typed out the DNA code from one person, the information from one person's DNA would fill enough books to fill Grand Canyon 78 times. That's the information to make you, Robert, and me. I may actually have a little more because I'm a little more than 50 trillion cells now, okay, because that butter pecan ice cream, okay. David said, I will praise thee, for I am fearfully and wonderfully made. From birth to conception, the baby adds about 15,000 cells per minute to its body. Each one of those cells is more complex than a space shuttle. You want to follow the development of the baby, how it follows the 7 feasts of Israel? See the 7 feasts of Israel by Zola Levitt. That is Levitt.com. Phenomenal. The stages of growth of the baby follow the 7 feasts. Whoa, okay, that's another whole story. The probability of just one DNA evolving by chance has been calculated to be 1 in 10 to the 119,000th power. That's a big number when you figure the whole visible universe is 10 to the 28th inches in diameter. Think about that for 10 minutes, okay? Even with DNA sequence data, we have no direct access to the process of evolution, so objective reconstruction of the vanished past can be achieved only by creative imagination. Yes, Robert and Corner Staple, it is pure imagination to think that DNA sequencing or phylogenetic trees, you can be like SpongeBob and imagine all you want, but it's not science, okay?
Natural selection weeds out detrimental mutations and selects for beneficial mutations, but the neutral ones, having neither cost nor ill effect, may freely accumulate as junk.
Beneficial mutations, if they exist at all, are absolutely rare. Any evolutionist will admit to this. Natural selection is a fine-tuning process. It's a selection process. You can check out my debates for more on genetic entropy with some of the best evolutionary proponents out there. For example, I would recommend watching my debate with Dr. Stefan Frello, especially the discussion portion where we actually do talk about neutral mutations and just mutation accumulation in general. Natural selection, it can remove the worst, most detrimental and deleterious mutations, and it can amplify the best beneficial mutations, let's say antibiotic resistance, for example, but it can do nothing. It can do nothing against those near neutral, low impact deleterious mutations. They accumulate like rust on a car. That's why the damage is largely invisible. And Aaron Ra here, it is clear that he doesn't understand mutations. He doesn't understand genetics as much as he may believe that he does. And the human mutation rate is alarmingly high. It's roughly 100 new mutations per person per generation. What this actually means is that mutations, they're entering the human population at a rate much, much faster than natural selection could ever possibly select away such mutations. It's like rust on a car. It's continuous end destruction. He believes that there are mutations that are absolutely neutral. And as I said earlier, as I said in my rebuttal to Godless Engineer, for example, that misunderstands the entire point at hand. Sure, it's neutral to the perspective of the organism's physical fitness or physical appearance, the phenotype, for example, but in no way can it be absolutely neutral to the genetic content or the genotype. These neutral mutations, the low impact near neutral mutations, the fact is that they have only a very tiny effect on fitness. It's like one single spelling mistake in a book the size of an encyclopedia. Is one single spelling mistake going to have an overall effect that's negative in the long run to that book the size of an encyclopedia? No, but it's the buildup, it's the accumulation of them that in the long run degenerates, destroys. So essentially, it comes down to the fact that harmful mutations, they're essentially invisible. Absolutely invisible to the natural selection process. Nobody disagrees with natural selection. Nobody disagrees with a beneficial mutation here or there. They're mostly reductive, for example, sickle cell anemia. But at the end of the day, no amount of rare beneficial mutations can counterbalance the information loss. The information loss based on the influx of near neutral deleterious mutations. So at the end of the day, this all indicates strongly that, for one, the human genome and apparently all genomes must be accumulating harmful mutations continuously, and that such genomes, as I've stated before, they are slowly rusting out. And all of this has been verified. The inevitable genetic degeneration process, it's been validated by extensive numerical simulation experiments, and even in biological test systems. You can see these for yourselves. For example, Dr. John Sanford. Therefore, it all comes down to the fact that mutations, Aaron Ra here thinks that mutations are the creator, but they are the destroyer. They break things, they destroy. For example, bacteria. They can adapt, but what it is, it's adaptive degeneration. They lose genes short term for adaptive purposes, but it's long-term degeneration. Mutations are destruction and not construction. Sorry, Aaron Ra.
How, mutations, a lot of them, they're not harmful, they're neutral, but that would misunderstand the entire point of, for one, genetic entropy, and two, neutral mutations in general. Because yes, most mutations are neutral from the perspective of the organism's physical fitness, right? The phenotype, of course, but all mutations must have effect on the genetic content, which is the genotype. So in no way are mutations truly neutral. All must have an effect on the genotype. In regards to his, new information, beneficial mutations, the thing is, a lot of them now, even if I gave him a couple, for example, it's still not going to counterbalance the damage. But a lot of it now is based on epigenetic markers, and they're used and acted to control and regulate the activity of our genes, right? So our epigenome can influence our physical appearance in much the same way as our genes do, but with no change to the underlying genetic code. For example, diet alters our teeth, swimming alters our spleen size, high altitude alters our chromosomes, hard work alters our bones. But the thing is, there's no large scale evolution, no new information is added, just expressed.
We define a beneficial mutation as a mutation that provides a benefit to the organism. In other words, I'm now resistant to an antibiotic, which is beneficial if that antibiotic's around. So if you look just at beneficial mutations, which is what evolutionists love to look at, beneficial, 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 and I say, but that's really irrelevant. What's happening at the genetic level? That's the key. It's not whether it's beneficial or not beneficial, it's what's happening genetically. And what we see, for example, with antibiotic resistance. Antibiotic resistance comes by one of two ways for the most part. You have a vector come into the organism, which is bringing in some kind of gene that makes it resistant. Okay, well, that vector already exists. You're not introducing anything new into biology, it's already there. So that doesn't account for the origin of anything, it just counts for how it moves around, okay? The key thing then becomes mutations. That's why evolution is mutation and natural selection. Because if you do change the sequence, that has the potential to give you a whole new genetic component, a whole new genetic activity. But when we look at mutations that cause antibiotic resistance in bacteria, What they are is mutations that eliminate transport proteins, eliminate enzyme activities, eliminate functionality of certain proteins, eliminate, reduce, cut down, eliminate. See, is there a trend here? Okay. With lactose utilization in a human. The reason I can drink milk is because the normal regulatory system that shuts down the gene that makes the enzyme so you can digest lactose, when you move through puberty, that gene gets shut down. If you have the mutation, that blocks the shutting down. But what have you done? What you've done is you've eliminated a pre-existing system.
Another example of new variants is the glycophorin A somatic cell mutation, which has been identified in some Tibetans, which allows them to endure prolonged periods at altitudes over 7,000 feet without succumbing to apoplexia or altitude sickness.
Well, basically, epigenetic inheritance is this new unconventional way of looking at genetics. Up until now, mutations were considered the only thing that could be either positive or negative in regards to fitness, because without mutations, evolution can occur. So this is where epigenetic comes from, and it goes against basically the idea that inheritance only happens through genetic mutations, or the DNA code passes on to the parent from offspring. This means that a parent's experiences in the form of epigenetic tags can be passed down to future generations. So epigenetics is the study of where factors influence a gene and how and when the gene is expressed. Regarding like the Sherpas of the high altitude people of the Nepal, the mainstream thought is that a single 1-point mutation led to a better adaptation for the high altitudes of the Tibetan people. But modern science has revealed that the epigenetic mechanisms are also behind this adaptation. It's not a beneficial mutation. You can read a peer-reviewed paper on this, on the epigenetic signatures of the high altitude adaptation of the Tibetan population. If you think about it like twins, twins have identical DNA. And think about it like one person turns 50 years old and so does the other one, right? But one will have cancer or heart disease, the other might not. One will go bald or be bipolar or start to lose their eyesight where the other doesn't. This is because of epigenetics. It's not inherited genetic mutations like we're told. Take, for example, the epigenome, which keeps a long life communication between environment and our genes that turn on and off tumor suppressing proteins. This is a reason why one twin will get cancer and the other will not, because epigenetic changes via the individual diet or environment it'll cause this. So when you hear about beneficial genetic mutations, you are actually hearing about epigenetic regulation, not beneficial mutations. This is why the Sherpa people who have been called beneficial mutations that allow them to thrive at this high altitude, yet when they relocate and have children, they pass on none of these beneficial mutations, so-called, for these high altitudes, because they have no genetic requirement for living at such altitudes. So again, it was never a beneficial mutation. It was already present in the gene that got switched on. Evidence showing that it's nurture over nature. So to make matters worse for evolutionary theory, epigenetic modifications themselves are actually often resulted in DNA errors. And this leads to gradual but inevitable DNA degradation as well. So epigenetic adaptation will never result in any kind of evolution, because epigenetic mechanisms only regulate pre-existing biological information. Since epigenetics is not mutation-based, and there is no actual proof for beneficial mutations anymore of all these things that we're talking about, like the lactose mutation. They claim that it was a single SNP, a single point mutation resulting in lactose persistence, but that's wrong. It's epigenetics like all the rest. It's actually a methylation level, MCM6 and LCT genes. So the more they look into the epigenetics, the more that they find that it's that relation and it's not a mutation at all.
And then there's a family in Connecticut who've been identified as having hyperdense, virtually unbreakable bones.
Fail again. This has nothing to do with beneficial mutations. This is just epigenetic regulation.
BCR5 delta 32 mutation. About 10% of whites of European origin now carry it, but the incidence is only 2% in Central Asia, and it is completely absent among East Asians, Africans, and tribal Americans. It appears to have suddenly become relatively common among white Europeans about 700 years ago, evidently as a result of the Black Plague, indicating another example of natural selection allowing one gene dominance in a changing environment. It is harmless or neutral in every respect other than its one clearly beneficial feature. According to ScienceFrontiers.com, if one inherits this gene from both parents, they will be especially resistant, if not immune, to AIDS.
There are people that are actually resistant to HIV. Do you know how they're resistant to HIV? They are missing the key protein the HIV virus binds to. And if the virus can't bind, it can't infect. Now, if you're exposed to HIV, that'd be pretty beneficial mutation, right?
Sure.
But what's it caused by? It's caused by loss of a pre-existing protein. And so what we see, and I can go on and on, what we see is repeatedly what the evolutionist community does is they offer example after example after example of what they claim, here's how evolution works. No, it's not. Because what you're doing is you're taking pre-existing systems and knocking them out or reducing them. You're not explaining how they evolved to begin with. It's the analogy of if you have a house, and in your house you have the dining room and a wall and then your recreation room. And your wife, being, the big socialite that she is, she wants a bigger dining room to entertain her parties. Well, you have a choice. I can keep my rec room or I can knock at that wall and get a bigger dining room. Well, everybody knows happy wife is a happy home. So you knock out the inner wall and they have a bigger dining room. And it's beneficial because she's happy. But don't tell a carpenter that how you built the house was by knocking out a wall. But that's what evolutionists do repeatedly is they give you an illustration of knocking out a wall, and this is how the house was built.
Genetic evidence is so reliable it can get a life or death sentence even without need of other types of evidence to corroborate it. So the unique fingerprints of mutation in molecular phylogeny are not only profound evidence of evolution, they amount to legal proof of it. Evolution of life is analogous to the evolution of language.
Oh good, I'm glad you think so, because language actually proves creation and completely falsifies evolution. If you don't think so, you're completely insane, and you should prove me wrong by debunking the video I made. It's only 10 minutes. I think you can make time for it, but I don't expect an answer.
So you said Hovind would have to concede that evolution is not a religion. I'm at the 1 minute, 3 second mark of your 18-minute closing commentary. Took me an hour to take care of 1 minute, Mr. Nelson. Evolution is a religion. I'm not going to concede. I will never concede that it's not a religion because it is a religion. You guys believe these things are related. You believe it very strongly. Will you ever concede that the first 5 meanings of the word are a religion? You're the one that needs to concede. You don't accept evolution. You believe in evolution. You kids got to watch them to use that word accept. Do you accept evolution? They're sneaking it in on you. Don't use the word accept. You believe. You do believe, I'm sure, but it's a religion. Mr. Nelson is very verbose. We just covered 1 minute of his closing comments. I'm not in a hurry to cover all 18 minutes, but I will, as needed, when I feel like it. You are low priority in my book. You have what's called the Dunning-Kruger effect, Mr. Nelson. You think you know a whole lot more than you really know.
If that sounds silly to you, imagine how much sillier it sounds to rational people who don't make believe in fairy tales like you do.
You guys can imagine anything you want. Go ahead. There's nothing to cry about, okay? I can shut you up.
I challenge you.
You might want to warn your wife.
You're irrational.
Good, shut up. Okay. Wow. Correct your idiocy.
I should have known better.
Kind of like a mosquito. You gotta just, once in a while, you gotta swat them.
Is there no one else? Is there no one else? Who are you, soldier?
Call me anytime. 855-BIG-DINO, extension 3. I'll be glad to explain it to you.